welcome to the Deep Dive. Today, we're incredibly excited to jump into a book that's really got us thinking lately. David Deutsch's The Beginning of Infinity. Seriously, get ready, because this one, it goes deep.
It really does. It's not just science, is it? It's about, well, how we understand anything.
Exactly, and the potential we have. Just, wow.
Think of this as a guided tour through some pretty big ideas about progress, knowledge, the works.
Deutsch basically argues, right, that our ability to come up with better explanations, that's the engine.
That's the engine. And he thinks it might be limitless,
Right.
which is quite a claim.
Yes. So today, we're tackling the first couple of chapters. They lay the groundwork.
And they're packed, seriously packed with stuff that might make you rethink, well, how you think.
Okay, so let's dive in. Chapter 1 kicks off with a quote Deutsch loves from Wheeler.
Yeah, John Archibald Wheeler. Behind it all is surely an idea so simple, so beautiful.
That when we grasp it,
Yeah.
we will all say to each other, how could it have been otherwise?
It really sets the stage, doesn't it? This search for simple, powerful explanations.
It totally does. And right away, Deutsch hits us with this amazing contrast.
The night sky?
Yeah, what you see with your naked eye. A few thousand stars, maybe. Pretty, but limited.
Compared to what astronomers know.
Billions of stars. Galaxies, insane distances, supernovae.
He mentions that gamma ray burst, right? 7.5 billion light years away.
Brighter than a million supernovae, just for a moment. It's staggering.
And the core question is, how on earth do we know that?
Right. We're stuck here. We can't go there.
Yet we have this incredibly detailed knowledge, and Deutsch says it's not just from looking.
No, it's the theories, the scientific theories we've built.
These complex explanations for how it all works.
Which leads him straight into tackling empiricism.
Ah, the old blank slate idea, John Locke.
Yep. The mind as a white paper.
Yeah.
Just passively soaking up experiences.
Like we just read the book of nature and boom, knowledge.
But Deutsch, he follows Popper here,
Yeah.
right? And flips it completely.
He does. Theories aren't derived from experience. They're not extracted.
They're guesses.
Bold guesses, conjectures, creative ideas our minds just generate.
So experience isn't the source.
Experience is the test. We guess, then we check. We see if the guess holds water against reality.
That's a huge shift in perspective. We're not passive recorders, we're active guessers.
Exactly. Constantly proposing ideas and then seeing if they survive scrutiny.
And this blows up inductivism too, right? The idea of just projecting the past onto the future.
Oh, yeah. The sunrise example. Just because it rose yesterday.
Doesn't logically guarantee tomorrow's sunrise. We believe it will, but based on deeper explanations.
Like gravity, orbits, astrophysics. Not just the pattern itself.
I loved his year 2000 calendar point.
That was brilliant.
We all saw 19-something our whole lives, but nobody panicked about 2000.
We expected it. Because our underlying theory of time and calendars told us what came next. It wasn't just repeating the past 19.
So predicting the future often needs more than just patterns. It needs explanations.
And science constantly predicts stuff we've never seen before. Flight, radio waves, things completely outside past experience.
Requiring totally new explanatory frameworks.
And even seeing a repeated event, like the same bird at the feeder, that assumes theories about what a bird is, what sameness means.
It's all theory-laden, isn't it?
Pretty much. So creating these new explanations, it's not mechanical.
It's creative, like writing a story almost, but one you then test rigorously.
We're not just reading nature's book. We're trying to write it, guessing the plot, then checking the facts.
And our guesses can be way off, like the old geocentric model. Earth at the center.
Seemed obvious. Fit the sensory data, in a way.
But completely wrong. Shows how easily senses or our interpretations can mislead us.
Which brings us to justificationism versus fallibilism. This is key.
Justificationism.
Yeah.
That's the hunt for certainty, right? For that final authoritative proof.
Yeah. How do we know this is absolutely true? What's the ultimate source?
And Deutsch says that quest.
Yeah.
That actually gets in the way.
It hinders progress because it makes you want to defend your current justified belief, not find flaws in it.
So fallibilism, accepting we might be wrong.
Exactly. Embracing that all our knowledge is provisional, no final authorities, everything potentially mistaken.
Sounds a bit bleak initially.
But he argues it's the opposite. It's the foundation for unlimited growth. The beginning of infinity, you might say.
Because if you accept, you might be wrong.
You're open to improvement. You seek out errors, you welcome criticism, you look for better ideas. The focus shifts.
From justification to progress.
Precisely. And that old empiricist focus on authority downplayed the role of guessing, of conjecture.
Like Sherlock Holmes saying, data, data, data. I can't make bricks without clay.
Sounds sensible, right? Get the facts first.
But Deutsch calls it a capital mistake.
Because you can't even get data without theories. All observation is theory-laden. What you notice, how you interpret it, it all depends on your existing ideas.
Like seeing shapes in clouds. What you expect influences what you see.
So the big mystery remains. How do these ideas, cooked up in our heads,
End up describing reality so well, especially distant reality we've never experienced.
it feels almost magical, and for most of history, we didn't have a good system for making this happen consistently.
Progress was slow, lots of reliance on tradition, authority,
People looked at the same stars for millennia with the same brains we have now.
but their understanding didn't leap forward until
The scientific revolution, the Enlightenment, this massive shift.
a rebellion against unquestioned authority.
That's the key phrase, nullius in verba. Take no one's word for it.
But just rejecting authority isn't enough, is it?
No, you need something else. A tradition of criticism, where ideas are actively challenged, tested, debated.
Okay, so testability.
Yeah.
That's crucial, right? Theories have to be potentially falsifiable.
It's important, yes. But Deutsch argues it's not the whole story, not the sole decider between science and non-science.
Because lots of things are testable but aren't good science.
Exactly. Myths, superstitions. You can often test their predictions. If I don't sacrifice a goat, the harvest will fail. That's testable.
But it's not science.
Right. Because the real goal isn't just prediction, it's understanding why.
The conjuring trick analogy.
Perfect. You can predict the rabbit comes out of the hat, but that doesn't explain how the trick works.
In instrumentalism, the idea, science just predicts, doesn't describe reality, misses the point.
Deutsch rejects that. He says even simple predictions rely on some maybe implicit explanatory framework.
Like background knowledge or rules of thumb.
Knowing dark clouds mean rain implies some explanation about weather, even if basic. There's always an underlying why.
Which leads to his definition of a problem. Not just ignorance, but a conflict between ideas.
Yeah, like an observation clashes with your theory or two theories contradict each other. Popper's all life is problem solving.
Love that. Problems aren't failures, they're opportunities. They show where our knowledge is flawed.
And need better ideas. Observation alone won't fix a flawed theory. You need a better theory.
And even testing relies on tons of prior explanations about how your instruments work, what you expect.
It's all built on previous knowledge, creatively modified.
Okay, so what makes an explanation good then, if testability isn't the only factor?
This is where he brings in the Persephone myth for seasons.
Right. Hades kidnaps Persephone, her mother Demeter grieves, causes winter, Persephone returns, spring comes.
It explains seasons. It's even testable seasons happen cyclically,
Wow.
but it's incredibly easy to vary. You could swap the gods, change the reason for the grief, alter detail.
And it would still predict the seasons just fine. The details don't really do anything.
Exactly. Compare that to the real explanation.
Earth's tilted axis orbiting the sun.
Right. Now that is hard to vary. Change the tilt angle. Seasons change dramatically. Remove the tilt, no seasons, make the orbit circular, affects season length.
Every detail is functional, it connects to other things.
It's constrained. That's the mark of a good explanation. It's hard to vary while still explaining the phenomenon.
So myths are bad explanations, not just because they're false, but because they're too flexible, too easy to change.
Precisely. They don't genuinely constrain reality. They can be adapted to fit almost anything after the fact. That's why they're unscientific.
So progress needs this constant search for better, harder to vary explanations, a scientific frame of mind.
Feynman's, the first principle is that you must not fool yourself, and you are the easiest person to fool.
It all comes back to seeking good explanations, rejecting authority, and embracing criticism.
That's the engine of the Enlightenment and science.
And these good explanations, like the tilted axis,
Yeah.
they have reach.
Yes. This is another key idea. The axis tilt theory, developed maybe in the Mediterranean.
It suddenly explains seasons at the poles, midnight sun, polar night, things the original creators might never have directly observed.
And seasons in the southern hemisphere being reversed. Predictions about things far outside the original problem scope.
That's the reach. It's built into the explanation's content, not just extrapolated.
Exactly. So, Chapter 1 concludes, this pursuit of good, hard-to-vary explanations within a tradition of criticism and fallibilism, that was the beginning of rapid, sustained progress.
Wow. Okay. That's a lot to chew on just from chapter 1.
It really is foundational stuff.
Let's move to chapter 2 then, closer to reality.
Right. And here he starts with scale again, the universe's sheer vastness.
But also brings it down to the human level with that anecdote about the Palomar Sky Survey plates.
Looking at galaxy clusters through a microscope.
It's such a striking image. These immense structures reduced to tiny specks of silver on glass.
And that process of cataloging them, distinguishing stars from galaxies from flaws.
Which we'll get back to. But first, his reflection on maybe being the first and last person to consciously see a specific distant galaxy.
It's profound, isn't it? Puts our individual existence in perspective against cosmic time and space.
Yeah, and he pushes back against feeling insignificant because of it.
Right. The universe's size isn't a reason to feel small. It's a measure of the reality we can potentially understand. More reality is better.
And wondering about life out there, their view of us.
It connects nicely to his point about scientific work itself. It's not just perspiration, as Edison implied.
The 99% perspiration.
Yes. Deutsch argues that even repetitive tasks in science can be deeply creative and enjoyable if you're engaged with the ideas.
Not just mindless toil. Like the difference between computer chess just calculating moves and a human player understanding why certain strategies work.
Exactly. Which leads beautifully to that moment of, oops.
Is that a galaxy or a star?
Neither. It's a defect in the photographic emulsion.
Oh, man. Talk about a reality check. Off by 50 powers of 10 in mass.
It perfectly illustrates how interpretation is everything and how easily we can mistake the cause of what we're seeing.
Which is his point, right? Errors in experiments are errors about the cause. They're theoretical errors.
And most of nature, especially the very big or very small, isn't directly detectable by our senses anyway. We need instruments.
And here's the paradox. Instruments physically put more stuff between us and the object.
Like a telescope versus the naked eye. More glass, more machinery.
But they bring us conceptually closer to reality. They make the imperceptible perceptible somehow.
And modern astronomy often involves no looking at all in the traditional sense.
It's signals, data, computer processing.
False color images, indirect inferences piled high.
Jocelyn Bell discovering pulsars from a wiggly line on chart paper.
A perfect example. It was her theoretical interpretation of that wiggle that let her see pulsars.
So as we probe deeper, the chains of interpretation get longer, more complex.
More theory dependent, which means more potential for misinterpretation if the theories are wrong.
But science corrects itself. That quest for good explanations, not fooling ourselves.
It helps us refine those interpretations. Think about adaptive optics and telescopes.
Right, correcting for atmospheric blurring in real time.
They actively use theories about light and atmosphere to remove distortions and reveal a truer image of the star beyond the twinkle.
So accurate observation isn't passive. It's active, indirect, and relies heavily on prior knowledge.
Always. And his killer point. Seeing a galaxy as silver specks isn't fundamentally different from seeing your garden via light hitting your retina.
Whoa. Explain that again.
Both involve local phenomena, silver grains, or retinal cell activations being interpreted by your brain using theories as evidence for an external reality.
Okay. It's all interpretation of immediate evidence based on underlying models of the world.
Exactly. Whether it's particle tracks as pixels or cell structures via electron microscopes on dead samples, it's the same principle.
We're looking at local artifacts to understand distant or inaccessible things.
And isn't it amazing that objects here detectors' eyeballs can accurately represent attributes of objects far away and totally different in composition?
It feels like magic. A reverse conjuring trick, he calls it.
And the magic is performed by our explanatory theories. They tell us how to build the instruments and interpret the results to reveal reality.
So we consider something real.
If it's part of our best explanation for what we observe, if taking it out makes the explanation worse or impossible.
Even if we can't directly touch it, like a distant star or a subatomic particle.
Right. We build instruments from earthly materials, look at the readings dots on a screen, numbers on a graph.
And our minds use those local readings to focus on the distant reality.
That's how we get closer to reality, paradoxically, through these layers of instrumentation and theory.
Okay, so wrapping up these first two chapters, it's all about the power of explanation.
Good, hard-to-vary explanations, that's the key.
And rejecting easy answers, authority, mere observation, embracing fallibility and criticism.
And understanding that even our most sophisticated observations are deeply theory-laden interpretations that guided by good theories, bring us closer to reality.
Which sets up this massive lingering question, doesn't it?
Can this actually go on forever?
Yeah. Can this process of creative explanation, testing, refinement, can it truly be infinite? Are there limits to what we can understand?
It really makes you think about that title, The Beginning of Infinity. Is it just beginning?
A perfect thought to leave our listeners with, and definitely something we'll explore more as we continue this deep dive.
For sure. Next time, we'll likely get into Chapter 3, The Spark, maybe touch on things like dark matter. Lots more fascinating territory ahead.
Absolutely. So make sure you join us next time for more exploration right here on the